Alright, for those of you out there who are wondering how to determine oxidation states of different elements, different atoms, let me give you an example here that is fairly involved, but once I show you the formal process and how to do this, you may not even need to set it up on paper. It might be something you can do in your head. Nevertheless, let's look at how this breaks down, and in order to do this, I'm going to set up a little chart. I'm going to say, let's have a chart that shows us our oxidation states of each atom. Okay, so that's when you see the term oxidation state or oxidation number, it's talking about for one atom. And then let's set up another part of this chart that gives us the net charge. Okay, and that's basically saying the total for all the atoms. Okay, now first thing we need to recognize is magnesium nitrate is a neutral ionic compound. One magnesium ion, two nitrate ions, they come together and they have a net charge of 0. So our net charge here needs to be 0. We need to make all these numbers work together to equal nothing. Now, the way this works, you start by finding some elements that you know off the top of your head, or you can look at their position on a periodic table to tell what charge they would naturally have when they interact with these other atoms or ions. So for example, if you were to look up oxygen, oxide, this is something we should pretty much know all the time. Oxide is almost always, excuse me, let me erase that. Oxide is almost always -2. Okay, that's just the way, that's one of those ones to memorize. Okay. And let's look at the combination here. How many oxides do we have? How many oxygen atoms are there total in this entire compound? Well, you see that 3 there, so there's 3 oxygens, but I have 2 of those groupings. So there's really a total of 6 oxygen atoms. And if each oxygen atom is -2, then this contributes a net charge of negative, I drew this in green, -12. Okay? So -2 for each oxygen, there's 6 of them, that gives me a total charge of -12. Now, you go over to nitrogen, well, that's kind of iffy. That depends on what it's with. It may have a couple of different oxidation states that it could be in. So let's go all the way over to magnesium. This is a metallic element. Okay, it always makes a +2 charge. Okay. Oops, I should be doing that one in red. Try and keep consistent here. That's a +2. Okay. Now, if that's a +2, and we only have one of those atoms there, then it contributes a charge of +2. Oops, let me put that in green. +2 for its net charge. Now, the reason I'm going through this in color coding is I want you to see we're missing nitrogen. We need to figure out what that is. I need to know what number I should put right here that's going to make all of this stuff equal 0. So 2 plus 10 minus 12 gives me 0. I just made that number up. Okay? Well, let's go backwards now and say, okay, if that's got to be 10, so nitrogen is going to have to contribute a net charge of 10, but I have 2 of those to split it up between. That means nitrogen's oxidation state must be +5. Each atom would be +5 to give me a +10 that would make all this stuff equal 0. And the long story short here is those are the oxidation states of each atom. Now, the only thing that will change is if you happen to just have an ion that's not a neutral compound, then you might have a charge here that's not 0, it might be a +1 or a -1, that you have to make all of these things balance out to equal. But the general process for setting them up is still the same. I hope that helps.